Hello, everyone. Good morning. So what is 5G? Well, we're going to have a chance to explore that topic in my talk this morning. But before we get started, we did have an opportunity to ask the average person on the street what 5G means to them, and this is what they said.
Hey everybody, I'm Sarah Sweeney, and we're here in New York's Grand Central Station asking real people what they know about 5G and some of the innovations it will bring. Let's go. Can I talk to you for a second about 5G?
Sure.
Cool, tell me about it.
No idea what it is.
Can you tell me what 5G stands for?
$5 grand. What's 5G as in?
The good thing about 5G is it puts a lot into a small package.
5G, it's I know that it has to do with Wi-Fi, right?
Is that the 5G that they do for the phone or the network or something like that?
Yeah. There he is. I say 5G, you say?
Internet.
There's no idea what it is.
The next thing past 4G?
Do you know what the G stands for?
I don't. Generation.
Yes, you are the first guy today. Good job.
Thank you.
If you have 4G, that's the 4th generation. So 5G is
5th generation.
the next generation. It's generation. It's the 5th generation
Oh my
of
god.
technology.
Oh my god, that's why we're in the 4th. God.
It is the new 5th generation wireless communications technology that has new spectrum approved by the FCC of 28, 37, and 39 gigahertz bands.
Yeah. You heard me ask somebody else and you looked it up on Wikipedia, didn't you?
Yeah.
Have you ever heard about Intel? Let me spit about it. It's 5G technology, and here's what's legit about it.
I believe it's fast,
Correct.
reliable.
If it would become real, I would be really happy.
5G.
Internet.
You got it.
Oh.
Guys, let's wrap it. We got this one.
So 5G is $5 grand. That's my personal favorite because I think my mother would answer it that way as well. So 5G is indeed the next radio standard following 2G, 3G, and 4G. But 5G is much more than that. 5G is the true convergence of computing and communications, where everything that can be smart and connected will be. With 50 times the peak data rate and a 10 times lower latency, 5G will enable new use cases and new capabilities that will transform devices, the data center, and the network as well. 5G networks will be more scalable, more agile, and more programmable, and will deliver new services that will drive a better quality of experience in our day-to-day lives. In a simple word, 5G is a transformative catalyst that will change the work we live, work, and play, and all that work is actually underway already. The printing press, the steam engine, the telegraph, the internet, what do these discoveries have in common? Well, they're all part of an elite class of socio-economic mainsprings known as general-purpose technologies. Established through a pervasive adoption across multiple industries, general-purpose technologies are catalysts of transformative change that redefine work processes and rewrite rules of competitive economic advantage. The profound effects arising from these innovations are positive impacts on human lives, elevating standards of living for people throughout the world. 5G has the capability of being a similar catalyst as these other general-purpose technologies. It has a significant role to play in industry transformation, not just in the evolution of communication, but in the evolution of businesses and society as a whole. 5G networks are a foundational building block that represent the convergence of computing and communications technologies, connecting everything and everyone from the device to the cloud and everything in between. When you have the capability of almost unlimited computing delivered to any device, whether it's a smartphone, a laptop, a tablet, a drone, a robot, as we'll be talking about later this morning, there are endless possibilities for what you can do. There are new use cases being developed for the Internet of Things today, including smart cities, smart factories, smart homes, all of them in early trialing, and with new innovations and applications that haven't even yet been imagined, coming with what we call the era of the machines. But the opportunity to innovate new life-saving applications is made even more possible with 5G, with the expanded bandwidth, the higher throughput, and the ultra-low latency that it will provide. So let's take a look at a few examples of how a combination of devices, an innovative network infrastructure, and the cloud are leading to new usage models in mission-critical applications. So with the recent path of destruction caused by hurricanes in the United States, it has brought to light the increased use of drones for disaster relief and recovery missions. All of this is being trialed with today's networks, but it will be more broadly enabled at scale with 5G. When the disaster hits, network connectivity is often the first priority of any rescue operation. In Puerto Rico, over 90% of the power and communications infrastructure was disabled by Hurricane Maria. Drones can actually be used to set up temporary networks in the sky, bringing communications and internet connectivity to thousands of users on the ground. And this is actually being demonstrated today. AT&T has something they call the flying cow, or flying cell on wings, that is bringing that connectivity to users today to give communications capability to thousands that are still without a wireless tower connection in their local area of residence. Beyond just the basic connectivity, drones can actually be used for research and recovery missions. If you think about drones being able to enter into disaster areas far away from the reach or speed of a human operation, you can actually detect objects, you can pick up audio, you can send camera images back to the relief and rescue operation. You have the ability to pinpoint with high levels of accuracy the person that may be needing rescue or recovery. And this is actually enabled even further by 5G technology, given the much higher levels of bandwidth and throughput that allows you to collect all of the data that you have on the ground and upstream it through the drone to the ground rescue operation. This is very different from the way LTE networks are designed today, which are more downlink heavy. Here we're talking about collecting and aggregating images and audio, feeding them up through the drone, and then downloading those down to the ground capability. And this can be extended to different types of flying vehicles like balloons or helikites, which are also being trialed today. In 5G trials that we've done, we've actually seen the latency as low as under 10 milliseconds, which is enabled by edge computing that is located much more near the place of disaster. And by having that computational capability in the network edge, you're able to have a much lower latency and consume as well as distribute large amounts of data. Another area that is being disrupted by 5G technology is medicine. Some of us are lucky to have access to excellent health care and an almost unlimited choice of physicians. But in other parts of the world, it's difficult to get even basic health care, much less health care where special skills are required. Through the use of high-resolution, real-time video streaming, we can enable doctors halfway across the world to be trained or directed by experts via immersive 360-degree video technology. And this high-definition, multi-angle visual streaming capability can be critical training or operating tools for doctors, with 5G delivering 10 times the amount of bandwidth and data rates over existing technology today. And by combining 4G, Wi-Fi, and the new millimeter wave capabilities of 5G, 5G can actually push throughputs of greater than 1 gigabits per second. And this could be the difference in terms of a real-time image being transported and transmitted in less than 10 milliseconds as compared to what would take as much as a minute or even an hour delay in today's networks. Public safety and enterprise security are two other areas that are becoming a focus in the world. Police and event security can use facial recognition to identify suspect objects or people and compare those images with an edge computing platform that has a database and where you're doing AI inference in real time and identifying a potential match. This can increase the safety of the venue, and certainly this can be expanded to large-scale venues and concerts to increase both public safety and the enjoyment of the event. That combination of artificial intelligence for facial recognition plus 5G bandwidth and low latency is a very powerful capability that we will deliver in the future. This end-to-end transformation to enable these and many other use cases is made possible with the transformational work that's happening today in the network infrastructure. So to take a look at how the network infrastructure is being transformed to bring 5G to life, let's take a look at another video.
It's no secret, today's business operations require far greater flexibility, agility, and efficiency than ever before. And that means today's networks need to transform to meet those needs. From software virtualization of key functions, to easy-to-deploy standardized architecture, to bringing a born-in-the-cloud approach to every upgrade and expansion. Today's best, most productive networks are a reflection of the businesses they support. From device to data center and everywhere in between, including the ever-expanding demands emerging at the edge. Because in today's world, your network is your business.
So yesterday in Intel CEO's keynote, you heard about the power of artificial intelligence and what AI in the network is can bring when we're all connected. Cloud and data center technologies such as data analytics and machine learning can bring new insights and advantages to the types of services we have now enabled through the transformation of the network. This analytics capability can be brought end-to-end to the network at various points, from the core of the network to the edge to the access network. Beyond that, when you look at the broad range of applications and use cases that 5G needs to enable, from the ultra-reliable low-latency communications like autonomous vehicles and telemedicine, as we talked about, or the massive machine type of communications that you have in a smart city with thousands or tens of thousands of sensors aggregating data that you need to turn into valuable insights. Or in the case of enhanced mobile broadband with 360 video or virtual reality or augmented reality, all of those enhancing the user experience, that immersive capability within the home or the enterprise. All of this requires a network that is highly composable in real time, where a network slice can be served up to meet the end user applications and the requirements of that particular use case without too much or too little use of the underlying infrastructure. So David is going to come up here to show us just how important latency is in some real-life applications that we have, to show and to demonstrate how 5G will make new experiences possible.
Sure, Sandra.
So David, show us what you have to demonstrate today.
Oh, definitely. I mean, we're going to show how latency is a factor that impacts real-time applications, and in some cases, make them impossible to do. To highlight this, I have a tilt table here, and there's two servos on each side, and they're being controlled by this computer. And its job is to keep this ball balanced in the middle. Now, this is a great example to help highlight that.
Yeah, so I want to see the latency, difference between 5G latency and a 4G network latency.
Oh, definitely I could do that. With it right now, I have it set to 5 milliseconds of latency between the computer's control to the servos. And what I'm going to do is I could just push that. And 5 milliseconds is really about in the range of the ultra-reliable and low-latency communications that you get with 5G. And you see it's really having no trouble and getting that ball back to the center. Now, I'm going to add 50 milliseconds to the latency. And when I do that, that's about average for 4G communications.
Or sometimes long, I think sometimes as much as 90 milliseconds or 100 milliseconds.
Pretty much, but this is the best case that we can use for that. And when I did that, now as you can see, I do the same push, and it's struggling, and it's actually getting worse and worse over time, and it's slamming into the walls. So you can see this is pretty catastrophic for any real-time application that you're going to do that requires computer control, and things like mission-critical applications.
Yeah.
That's bad.
Thank you very much for that, David.
You're welcome.
So that illustration really hones in on why reduced latency is key for all these mission-critical applications that I've been discussing. The difference in latency between 4G and 5G can mean the difference between a drone colliding with a physical object in its path or being able to steer clear to reach somebody in need of rescue. If we look at the rising amount of data that the network operators have to transport and manipulate and store in today's networks, that amount of data continues to grow exponentially year after year, much of it video data. So the network operators need to continue to build out capacity to service and support all of that data for whether it's connection between people or connections between things. But traditionally, the way the network infrastructure has been designed is using fixed function purpose-built hardware that is difficult, if not impossible, to reprovision to do anything else. And that's despite the fact that much of that hardware sits idle for much of the time. With modern architectures, network operators are now embracing server, virtualization, and cloud-based technologies and architectures to be able to deploy new capabilities at scale at a much more cost-effective point with higher asset utilization, and also with the speed of software in terms of provisioning new services as opposed to provisioning in purpose-built hardware. So what I wanted to show is that if you look at the way the network operator's infrastructure is designed today, much of it is roomfuls of these purpose-built different black boxes that have custom programming environments and require specialized skill sets for provisioning as well as for maintaining the equipment. But what most of the global service providers are moving to is just a standard 2U. This is a standard 2U server. If you're in the core of the network, you would potentially have a rack of these to service your requirements. As you get closer to the edge and the axis of the network, you can scale this down to just a 2U unit. But even further, as we were talking about getting close to the drone or the robot or the autonomous vehicle, there's a strong desire to have something that can actually be situated on a light pole or a telephone pole or even street furniture in a city. And this particular unit weighs just a couple of kilograms and has within it 2 different boards. Here we have an FPGA board, which is a field programmable array board, which allows you to reprogram the stack that's running on this particular piece of hardware for things like evolving security algorithms or an evolving 5G network standard. And the motherboard is a high-performance, highly powerful CPU server platform. So this together can do all the types of processing to bring mission-critical applications to the endpoints in a cost-effective, light, and small footprint manner, which is required in tomorrow's networks. So this idea of moving more compute to the edge of the network is something that AT&T's President John Donovan spoke about yesterday in his keynote. And in fact, Intel is working with all the global Tier 1 service providers to embrace this idea of edge computing, bringing more capability, more of that programmable computing platform close to the endpoints and the end consumers of the service. We're working with AT&T, with Verizon, with China Unicom, with Alibaba, Tencent, as well as Telia, to embrace this idea of edge computing. Another area that Intel is also working with a number of partners across the globe is where we can bring innovation to sports. So For centuries, the Olympics have served as the premier forum for testing the limits of what's possible, and Intel is very proud to continue with that tradition. Our end-to-end infrastructure capabilities, coupled with our mobile trial platform, will bring the future of 5G to the Olympics Winter Games in Pyeongchang in 2018, just a few months away. We recently announced that we're collaborating to deliver the first broad-based, broad-scale 5G network infrastructure with Intel 5G technologies. And we're enabling groundbreaking new capabilities like wireless broadband at gigabit speeds, ultra-low latency video distribution, and live-stream immersive content from that event. This 5G experience will underpin powerful edge and core network processing capabilities, all delivered with Intel high-performance processors. Our industry collaboration to deliver the Olympics' first 5G network infrastructure will illustrate the transformative power of 5G. So I hope you've seen that the network transformation is an imperative to enable 5G, enabling to support the key performance characteristics required for future services. Even though large commercial deployments are not expected until 2020, all of the network infrastructure is being conditioned today in order to get ready for those large-scale ramps. Beyond simply voice and data, 5G networks will enable integrated visual, tactile, and cognitive capabilities to support a wide variety of use cases with unique connectivity and device requirements, as we've seen both in mission-critical applications, use cases, as well as in entertainment and in sports. 5G is happening now, and we invite you to join us in an effort to accelerate the 5G future. Thank you.